All right, well, you have your exam in our next lesson, lesson 43. And so let's review some things. Have out some paper so you can jot some things down, some notes to yourself of what to study. Obviously, you've got your notebooks tonight. You'll study over those. But if there's something that I'm asking and you're like, ooh, I didn't know that term, or I didn't know that axiom, or that postulate, that informal statement, rather than try to write the whole thing out, which you won't have time for, just jot down the term or the number of the whatever, or something from class notes. For instance, ways to prove triangles congruent. We should be really well versed in this. Abby?
In alternate interior angles. No.
Let's rewind here. All right, so we get started with this review. One of the things we've done a lot with it lately is prove triangles congruent. Abby, we should be well versed in this. What are some of the ways to prove triangles congruent?
SSS, and then LL and LA.
There we go. Of course, the latter two class only for right triangles. So if the proof does not say this is a right triangle and this is a right triangle, or these are right triangles, could we use leg and leg angle? No, because they specifically say two right triangles are congruent. You have to prove you have right triangles before you use those. We talked about some different ways to prove that lines are equal to each other. We had a couple ways, 2 ways to prove lines are equal. Lana?
Was it opposite sides and opposite angles?
Okay, if they are opposite equal angles in a triangle, then the lines are equal. What's the other way to prove lines are equal?
Sides. Opposite. Wait, no.
Well, they would be the opposite sides.
Wasn't it getting two triangles congruent and then using CPCT?
Yeah, if you had congruent triangles, you could use CPCT. So that's a couple ways to prove you have lines equal. We have 3 ways that we could use, 3 or more. 3 ways in which we could try to get some angles equal. So if we're in a proof, we're like, ooh, I want some equal angles. There's a few different ways to get some equal angles. Brandon?
Parallel.
If you have parallel lines, that's going to give you a lot of different possibilities for some equal angles. What else?
In a triangle, angles equal, opposite, sides are equal.
Yeah, if the angles are opposite equal, that's an equal sign, opposite equal sides in a triangle, you could get angles equal. And the third way?
Get congruent triangles or use CPCT.
If you happen to have congruent triangles, you could use CPCTE. Some different ways to prove lines are parallel to each other. We've got 6 ways to prove lines are parallel. And Dylan?
Opposite interior, alternate interior.
There we go. Because opposite has the idea of being on the other side from something. Alternate means opposite sides of the same thing. So we use the 2 terms a little bit differently. So alternate interior angles equal.
Alternate exterior.
Okay, we have equal alternate exterior angles. Corresponding angles. That's 3 of the 6. 3 more ways to prove lines parallel.
They're both perpendicular to the same line.
All right, if they're perpendicular to the same line.
Parallel to the same line.
Parallel to the same line. You got the easy ones. There's one more. It's kind of it's a long one to say and write. You already helped me. Somebody who hasn't helped me yet. Like Michael. He's like, no help here. If this is on the test tomorrow, I'm in big trouble. You are. All right, Brecken. I'm going to draw a picture.
Oh.
If the sum of the 2 interior angles on the same side of the transversal equals a straight angle, they're going to be parallel as well. So alternate interior angles equal, alternate exterior angles equal, corresponding angles equal, perpendicular to the same line, parallel to the same line, or if these 2, and they don't have a name, but if those 2 equal a straight angle, or if those 2 equal a straight angle, that would work also. Yes, ma'am?
Technically, does that work for the exterior angles too?
It's not something that we proved, so we don't have it on our list, so to speak, but technically, if you were to say, if 2 exterior angles on the same side of the transversal add up to a straight angle, but again, you could easily then just go vertical to that, and frankly, this is, less frequently used anyway. You'll see why we mentioned this one in the corollary, and you'll you'll never see occasion to use this one. This one will come up again, so that's the reason we took the time to mention it, kind of setting the stage for what's coming. All right, good question, good thoughts. Any other questions on that? We got some Clang statements we need to know. For instance, if somewhere in the given you see perpendicular, Clang, what's our response, Michael?
Equal angles.
Nope. Adam? What does perpendicular tell me?
Two right angles.
Right angles. Perpendicular tells me I have right angles. Now, right angles then are equal, so in 2 steps we could get to equal angles, but perpendicular means right angles. If I see bisector, specifically an angle bisector, back to Michael, what's the Clang response to angle bisector?
Equal angles.
2 equal angles. Or if there's 2 different angles that are bisected, what's the other way we could word it? Anyone? Equal halves. Again, we won't need that all the time, but if there's 2 different angles and they're both bisected, oftentimes having equal halves will help. If I see midpoint in a given, or midpoint comes up somewhere. Dylan?
2 equal segments.
2 equal segments. If I see equal sides of a triangle, what's the Clang response to that? Noah? Equal opposite angles. What if I've got equal angles in the same triangle? Brecken? Equal opposite sides. And the next one's sort of a quasi-Clang, but if I have parallel lines in the given, what's the Clang response to that? Joshua?
They're gonna have equal angles.
Some kind of equal angles. Now, they could be any of these sets, right? But somewhere, somehow, I'm probably going to need some, or use some equal angles, get some equal angles from those parallel lines. We had a couple of things in our class notes that dealt with an isosceles triangle. One of them said this: if you bisect the vertex angle of the isosceles triangle, 2 other things are true about this line. What 2 things are true about that line that bisects the vertex angle of an isosceles triangle? Abby?
It forms 2 right angles.
You're 1 step ahead of yourself. Go back 1. Why would it form 2 right angles?
It's the midpoint.
Okay, that's not why it would form right angles, but it is true. Okay, so we would get equal segments of the base. Okay, so these will be equal to each other. If we bisect the vertex angle, it'll bisect the base, or go to the midpoint of the base. The other thing, there's a second thing,
It's
perpendicular to the base. That's the other thing. All right, then we also had, we need to adjust the camera here. We said if we've got an isosceles triangle, and I draw a line to the midpoint. I draw a line to the midpoint. 2 other things are going, yeah, it just doesn't quite fit. 2 other things will be true about this line. What are those things? Brandon?
It bisects the angle.
I'm sorry?
It bisects the vertex angle.
Bisects the vertex angle.
And
And
it's perpendicular.
it's going to be perpendicular to the base. Okay? So we proved a couple of those things there in your class notes section as well. Go and get your compass and straight edge at the ready. And now the constructions, there's 8 constructions we did this quarter. 3 of them are for triangles. I'm not going to necessarily revisit those because they're not foundational. But the other constructions are foundational to constructions we will see later in the year. So you don't usually take a triangle and do something more with it, but you'll take the other constructions and do more. So compass and straight edge at the ready. And let's go and do just a few constructions here. Make sure we're ready. You won't have 5 on there, but you will have a couple of them, and there will be a couple of these 5. So our first construction, if you would draw a line on your paper, make it a couple inches long, a couple few inches long,
Like diagonally.
however you want to draw it. I'm not picky. If I want to construct the perpendicular bisector, we're going to be able to need to do that. We're going to need to be able to do that, I should say, on several constructions coming up later on this year. So let's make sure we're good to go with doing the perpendicular, constructing the perpendicular bisector of a line segment. And Lana, what do we need to do to bisect, perpendicularly bisect, I should say, a line segment?
Did you put a point on it first?
No. The perpendicular bisector will go through the midpoint. I don't know where the midpoint is yet. So I can't put a dot on it first.
Didn't you mark it off?
Mark what off?
Both sides?
Mark.
No. I'm trying to remember how.
Perpendicular
But you put
bisector.
the point on one end,
The point of the compass?
on one end, and then don't you make an arc above? Yeah, I think that's what you do. And then you go to the other side, and then you make another arc. Like, oh wait, no.
It's a good thing we're reviewing, right? And that's the point of this. It's been a while since we've done these
Should
constructions.
open it up more than that?
Okay. Or like way more. Noah? She's your cousin, help her.
You open the compass more than half.
Yeah, you just got to be more than half, right? So as long as the compass is open, more than half. So it could be this far if I could reach. That's going to be the problem I'll run into. So just make sure it's more than half. And then you're right, I will make an arc up above, Lana, but also
And below.
and below. All right? Then what has to happen back to Noah?
Then you go to the other side.
And I don't close the compass.
No, and then you make intersecting arcs on both ends.
Good. Keeping the compass open the same amount. Again, if you adjust the compass at all, you'll still get a perpendicular, but it won't be the perpendicular bisector anymore. And this is specifically used when we need a midpoint. So this is used to actually locate the true midpoint of a line. Apparently that point right there is my
I
midpoint.
just forgot to say more than half.
It's okay. All right, so again, hence the reason for the review. All right, another construction, to Lana's point, speaking of point, she said, well, you could put a point on the line, couldn't you? And so let's go ahead and put a point on a line, and let's put a perpendicular at that point. So pick a point, not necessarily the midpoint, in fact, ideally not the midpoint, and let's construct a perpendicular right at that point. Dylan?
You take the compass, or the point of the compass, and put it on that point. This smaller cup where it fits inside. Open it up so it's shorter than the shorter side.
Okay, shorter than the shorter side. Basically, you don't want to have to extend things because you're lazy. So open it up so it's not as wide open as the short side would be. Okay?
And then draw an arc that intersects the line on both sides.
Good. So you're going to make an intersection mark on both sides. Again, the same size of compass open on both sides. All right. Let's see now what. Josh? These two little marks.
You put the point of the compass on one of the marks or intersections.
All right.
And then you open it a bit more.
Good. You've got to open it wider than you had it before. Not so it could be this, but wherever. It's just got to be wider than it was before.
Make an arc above. And then go to the other point.
Good. We don't need the mark below, though it's not wrong to, but go to the other side.
And then turn your compass and then make another arc.
Good. Again, this time both of these marks need to be open the same amount, and then we just
Connect the dot.
connect the dots. And there's our perpendicular. All right. We had added a perpendicular another way as well. If I had a point that wasn't necessarily on the line, but I wanted to construct a perpendicular to a line from some outside point. Let's see, what could we do here? Michael?
You take your compass and place it on the point that you made,
Or that was provided on the exam.
open it greater than the distance of it from the line.
Okay, good. So you're going to kind of open your compass to the line and then go just a little bit past. Way past is going to be a problem, but just because it's inconvenient. But open it a little bit past the line.
And make a mark on both sides of the line, an arc that marks through both sides.
Okay, make an arc, a long arc that happens to intersect the line twice. So A little bit of an umbrella look. If it was the other way around, it'd be the smiley face. So make that arc so that it cuts through the line at 2 points. If you miss the line, for instance, if I did this, we see that this misses the line. What are my options?
Extend the line.
Extend the line or
Close it.
close the compass a little bit. All right, so you make the arc. Once you've made that arc, it really doesn't matter how much you keep the compass open, though generally I just don't change it because I'm lazy. Bracken, now what?
You put the point on one of the intersections.
Good, I've got 2 intersections here. We said we needed those, so I put the point of the compass on one of them.
And make a mark above the.
Good, if I make a mark below and I haven't changed the compass, all it's going to do is it's going to hit this point again. So when you want to make the mark on the opposite side of the line, since my point is below, we're going to go above. If your point was above, you'd go below. Make an arc.
Go to the other intersection point.
Good, and now whenever I've got the compass open, it needs to stay that way when I go to the next intersection and...
Make a mark there.
Okay, and then class,
Connect the dots.
just connect the dots. And there's our perpendicular. All right. We also had a construction in which we could bisect an angle. So go ahead and draw an angle. You can draw it however you want, if you'd up to, some not too big. Just don't make a straight angle, that's kind of cheap. But acute or obtuse angle. Reflex angles get dicey. So stick with acute or obtuse. You could even, I guess, go right if you really wanted to. We've got to be able to bisect an angle for some of our future work that we will do. What do we need to do in order to bisect an angle? And Adam.
You take your compass and you open it, and then you take the point and you put that on the, what do you call it, where
What
the
do we
two
call
lines
it?
meet. As like a, on like a vertex.
Vertex, good. Put the point of the compass on the vertex.
And then you put it on, hopefully on like that and that line right there, and then you draw it across to the next line,
Okay, so you make an arc then that goes through both sides.
and then you open the compass a little bit more.
Okay.
That's a little bit easier.
Sometimes you need to, sometimes you don't, but hey, why not, right? Just keeps it consistent. So you open a little bit more.
And then you put it on one of those 2 points now,
Intersections, yeah.
and then you draw an arc.
Again, you know the bisector is going to be kind of around here anyway, right? I know it's not going to be down here. I know it's not going to be up there. So kind of go where you feel like it's going to go. Should I open it more again?
No.
No, once you've gone to one of the intersections and made an arc, you got to keep it open the same amount.
And then you go to the next intersection, and then you draw an arc. The point where the intersect is just draw a straight line down.
Straight line down.
Well, it says from the vert.
Oh, to the vertex. All right. And there we go. All right. Last one. Go ahead and draw. Let's make it, whatever you didn't do last time. I did acute last time. We'll do obtuse this time. And the last construction is to be able to copy an angle, or that is construct an angle equal to a given angle. Construct an angle equal to a given angle. And let's see here. Is anybody feeling left out, neglected? Lana? All right, Lana, here we go. How do we copy an angle or construct an angle that's equal to this one?
First, you draw another line.
Could you draw another line? Now, I usually go with something that looks horizontally, because usually we get a line that looks kind of horizontal. So I'm going to go with a line that looks horizontal, and I'm going to make it look about the same length as this one. So just draw another line to get us started. Good, then what?
Then don't you measure the first angle?
How do I measure an angle, though? You're right, I do measure the angle, but not with my protractor, but with my compass. How can I measure an angle with a compass?
You draw an arc first.
You do draw an arc first. Good. So we'll go to this.
Point.
Compass slipped. Okay. So we'll draw our arc.
Yeah. And then you put your point of the compass on the end.
Right here?
Yeah,
Are you
that-
saying the end or on the
The
intersection?
intersection.
On the intersection.
And then you measure how. Don't you measure how big the arc is?
Yeah, so that's how you'd measure an angle, is by simply measuring the arc that you've made. Then what?
Then you go onto the straight the line, and then you go to the end point. Of the left.
Because this didn't go to the end point, did it? This was on the
Oh
arc.
wait, don't you mark it first?
Mark what?
Oh, you already did. I think.
There's one little thing she forgot. I want to see if she. Give you a moment.
Don't you measure the
You're all right, because this is how you measure an angle, but I'm missing something over here. Somebody come to a rescue, Adam?
You take the point where they intersect and you put your point on the vertex and then match up the point where they intersect. And
Okay, because what are we trying to do? Give me a big picture here. We're trying to put.
draw an arc on one
Yeah,
side.
we got to get an arc over here too. So you make an arc here, we need
Oh,
that
yeah.
same arc over here.
I
So
forgot.
I'm just, rather than try to measure what I already did, I'm just going to make a bigger one and kind of get a fresh start. So I'm going with the bigger arc. And we got to come over here and make that same size arc. So your idea of how to measure the angle was false. You measured it perfectly. It's just you can't copy it over if you don't have an arc over here.
Yeah.
But then we will do what Lana said. We'll measure from intersection to intersection. Make sure you make that mark so that you can see where it's at. You confirm it's perfect. Come here, make that same arc. And then class, connect the dots. And we'll have copied that angle. And there we go. Questions on constructions? Again, you've got the notes in your what you call notebook, and so you'll be able to use those as you need to look over things and practice some more. But again, focus on the first 5 constructions. We've also done a fair bit of math lately with lines that are parallel to each other. So that's not a straight line, is it? Let's pretend that's a straight line. How about that? Does that look straighter? Yeah. Other line didn't turn out so straight. All right, so let's go with something like that. So a couple of parallel lines, we'll call them M and N. A couple of transversals, we'll call them Q and T. Cutie. Anyway, we'll number the angles. We got 3 angles there, 4, 5, 6, 7, 8. Let's suppose I know that angle 3, I just realized I need to come over here, sorry Gavin. Angle 3 is, it looks like about 95 degrees in the picture that I've got. And let's suppose angle 4 is, it looks pretty big, it looks like it's, I don't know, about 145 degrees. All right, so there's your given information. I want you to find all the other angles. Find the other angles in the picture. That's why we're working on it. So you can overcome this struggle.
Oh, find all of them?
Yep, find all the other angles. So there's 8 total. I've given you 2. That leaves you 6 to find. All right, give me an angle that we can find right off the bat. Lana?
Well, isn't 8 145?
Good. Angle 8, the vertical angle, has to be 145 degrees. Another angle we can find right off the bat. Brandon?
Angle 7 is 35 degrees.
Okay, because it's the supplement of angle 4 or of angle 8, either way, so 35 degrees here for angle 7. Michael?
Angle 6 is, 50 degrees. Oh wait, we haven't done that.
I'm not sure how we get
Angle
6
5 is
yet.
35 degrees.
Okay, angle 5, of course, is also 35 degrees. All right, let's go to Josh.
Angle 6 is 50 degrees.
How'd you get that? Michael just said it. I mean, how did you get that?
Cause
Statements, reasons. It is 50 degrees. Reason. Michael just said it
all
was.
the angles in a triangle add up to a straight angle.
There we go. Okay, so we're going off that assumption that the 3 angles will add up to a straight angle, and it is correct. We just haven't proven it yet. So 6 is 50 degrees. Let's see here, Brecken.
Angle 2 is 35 degrees.
How do we know?
Corresponding with angle 7.
Okay, yeah, okay, it corresponds to angle 7. Good. I was locked in on the alternate interior right here. I was like, wait, that's not right. Yeah, it is. It's corresponding to 7. Good. So 35 degrees there. And Dylan, angle 1 is yours.
50 degrees.
How'd you get that?
It's corresponding with that. It's also the missing angle from a straight angle, because 1 plus 2 plus 3 equals straight.
There we go. We got a straight angle here, 1, 2, 3. So that gives 50, or the corresponding angle, which is the easier, quicker way to get it. These are correct. So how many got all 6 missing angles correct?
No.
All right. Feel like we got a handle on it now? All right. Questions at all? All right. Well, we are going to do a little bit different thing now for the last 20 minutes of class. We're going to do a terms review at the board. Now, unfortunately, Gavin, because I'm going public with the video, I can't put the students on camera, so I'm going to aim the camera at the back of the room. So, Gavin, unfortunately, you only get to see me. I'll ask the questions. I'll have you guys come up to the board, because you can be the first to write the answer. Okay, so let me go ahead and end this video, and we'll pick up with part 2 in a second.